This module covers the factors that cause the ozone hole to form in Antarctica. The ozone hole is transient in that it's not present or only a few million kilometers in area during some of the month from January here to July. Now, in these months, there is basically no ozone hole, or it's so small that it's not really a ozone hole. But starting in August, the hole starts to expand and reaches a peak level at around September and October, where it's more than 20 million kilometers squared in area before it finally starts to close and eventually disappears at around December. And here we can see the cause of the ozone hole, which is the breakdown of ozone. So from January all the way to July, the ozone levels are rather stable around 250, but in August it starts to decline and it reaches its minimum at around September and October, which is around less than 150, so that's like less than half of the ozone is remaining. And this also coincides with when the ozone hole is at its greatest, and afterwards when the ozone hole closes up is when the ozone level starts to pick back up again, and once it goes back to normal levels at around 250, the ozone hole disappears in the end of December. This graph here shows the monthly temperatures in the Antarctic, and at the beginning of August is when the temperature is lowest at around -90 degrees Celsius, and this is also when the ozone hole starts to form, because the formation of the ozone hole is triggered by the very low temperatures in the Antarctic. And also the Arctic has a much higher temperature than the Antarctic, which is also why the ozone hole in the Antarctic is larger than the one in the Arctic. Very low temperatures in the Antarctic allows the formation of polar stratospheric clouds, or PSCs, and surface reactions on these PSCs converts reservoir species of chlorine, these two, which do not degrade ozone, into reactive species of chlorine, which do degrade ozone. And this conversion requires sunlight. So while polar stratospheric clouds can be formed in around August, which is when the temperatures in the Antarctica is at its lowest, we don't see the ozone hole becoming much larger until around September and October, which is when sunlight is present in the Antarctic. What's also important to notice is that there is a NOx being formed here, and this NOx sediments out of the atmosphere. So this NOx is now gone from the atmosphere, and NOx is what sequesters chlorine. So without NOx, nothing lowers the level of chlorine. And chlorine degrades ozone, so this is being degraded, and chlorine itself is not degraded, but rather it recycles. So it's a catalyst that it lowers ozone levels, but its own levels are not lowered, which is why it's able to continuously degrade ozone and lead to the formation of the ozone hole without using up all the chlorine. And this ozone destruction can occur by several pathways. It can also involve bromine as well. So in the Antarctic, there are these strong winds that circle it called the polar vortex. So these strong winds circling the Antarctic prevents air from the lower latitudes from entering the Antarctic. And once the ozone hole reaches its maximum in around September and October, the temperature warms up and PSCs disappear, which means reservoir species of chlorine are no longer converted to the reactive form. And the polar vortex also disappears. So Now air from the lower latitudes can flow into the Antarctic, and air from the lower latitudes carry NOx, which sequesters chlorine in this reaction. And now that the chlorine is sequestered, it no longer reacts with ozone, and since ozone levels are not decreasing anymore, the ozone hole is reversed and sealed eventually.